You're a professor of neuroscience. You are multiple award winner. You hold many research grants. You're the mother of 2 boys. And you're my friend. And last year you gave me the great honour of delivering my Chancellor's lecture, which was packed. We could have sold the tickets many, many times. And today I've given you an honorary doctorate at Edge Hill. What does it mean to you to be part of Edge Hill? How do you feel about us as a university?
It's such an honour to be part of Edge Hill and to have given the Chancellor's lecture back in November and now to be awarded the honorary doctorate. I mean, I think what I really like about Edge Hill is the atmosphere on this really, really beautiful campus. You can there's a buzz, and both times I've been here I've experienced that buzz, and it's a real privilege to be part of it, but also the history of Edge Hill being the first teacher training college for women. We're wearing suffragette coloured robes. That's really special. It's a real honour.
Well, it's an honour for us, and also, I guess, giving honorary doctorates on the day when we're also graduating a lot of students who've worked really hard for their degrees. You know, our honorary doctorates are role models, and obviously, for me, as a psychologist, as a woman in psychology and in science, you're a huge role model to many women. In fact, you're seen as one of the top 100 women in science. You're also involved in the public engagement in science. How do we get more women into science, do you think?
I think there are different answers to that question. Actually, one issue is it's not a problem getting women into science. For example, I helped to run a neuroscience doctorate, a PhD program at UCL, and we have many more than 50% applications from women, and we allocate more than 50% of the places to women. That's not a problem. It's the problem is keeping them in science. So there's this sort of leaky pipeline as you go up the ladder, where women much more than men drop out at various different stages, postdoctoral or early career stages. And the question is why? I think the answer is probably multifactorial. There are lots of reasons why, and it's a real shame, because one of the reasons is that women don't see science as a family-friendly career. It's very high pressure. You have to work hard, but actually, in fact, the reality is, yes, it's high pressure and you have to work hard, but it actually fits quite well with having a family because of the flexibility it confers, compared with other jobs where you have to be in for certain hours and there really is no flexibility in terms of picking your children up from school or being at home with them when they're sick. Actually, science, you can do it any time of the day or night and you can work around having a family. So I think that kind of message needs to be there, but in the form of role models. So women who are scientists who have families, to show that it can be done.
You have 2 little boys, 8 and 10. Your husband's also a scientist. He also works at UCL. Yeah. You write, you broadcast, you research, you lecture, you supervise. You also advise on policy nationally and internationally. How do you do it?
It's a big juggle, juggling a family and a career like that. My husband does half of the childcare. We split everything 50%, which is a huge, support for each other. And we were also lucky enough to, when our children were young, to be able to have a nanny for both our children, and that really, really helped be able to kind of go back to work after 2 sets of maternity leave. And I think it's just being, efficient with your time, but things have to give. And, for quite a few years, I had very little social life. Because I had these small babies and trying to run a neuroscience lab and build up my own career. But yeah, it's a big juggle, but it can be done.
You're the queen of the adolescent brain. And you've really not just kind of expanded research into the adolescent brain, the teenage brain, but you've also you've really pushed the frontiers of how we think about the adolescent brain. How did you land there? How did you decide that was going to be your area of specialism?
Okay, so I did my PhD on schizophrenia, which is, as you know, a condition, a psychiatric condition that's characterised by things like hearing voices and being paranoid, and that's a condition that has its onset. It normally develops right at the end of adolescence, between the ages of 18 and 25, and I noticed that. I mean, I knew that, we've known that for many decades, even centuries, but I noticed it when I was testing patients in psychiatric hospitals. I would ask them, before I tested them on experimental tasks, when was the first time you experienced these symptoms? And without a single exception, 80 or 90 patients, they all said some age between 18 and 25. And it occurred to me at that point, that was almost, 15 years ago, it occurred to me that this is a really interesting phenomenon, that this very severe and florid illness has its onset right at the end of adolescence. And the question was, or the question still is, what goes wrong in the developing brains of teenagers who then go on to develop schizophrenia? And back then, 14 so years ago, there was virtually, very little known about how the teenage brain develops, even in typically developing teenagers, let alone in teenagers who then go on to develop schizophrenia. So at that point, I decided that that's what I really wanted to study. And since I don't know, 13 years ago, I've been doing that, studying the development of the adolescent brain.
And it's your passion. I mean, I've seen you speak a lot, we've shared platforms, we've also spent time thinking together, we keep threatening to write a book together when we can find the time. This is your passion. You are absolutely passionate about it. And as an academic, you're also passionate about it from a sort of more social and moral perspective. Can you tell me a little bit about that?
Yeah, I am passionate about it. I think one of the things that makes it such an exciting field is that it's very young. So there are still many, many questions yet to be even looked at, let alone answered. There are many more questions than answers. For example, we have no idea how, for example, playing video games or going on Facebook a lot affects the developing teenage brain. They probably do affect it, but we don't know how. We know a little bit, but not very much, about how things like alcohol or drugs affect the developing brain. We don't know how culture affects the brain. So maybe, the brains of teenagers in different cultures look different. We just don't know that. There are so many questions that have yet to be answered. The question of mental illness. Why do so many mental illnesses start in adolescence? People are starting to look at the brain basis for that phenomenon, but only just starting, and we don't have any full answers yet. So that's what makes it such an exciting field. Another reason why it's so exciting is because what we do know points to huge development. So we know that the adolescent brain undergoes really substantial and protracted change right across the cortex in most of the surface layers of the brain, right into the teens and even the 20s and early 30s. And that makes it an exciting and intriguing area to study, because we know that this development is going on. We know that this development must be influenced by the environment, for example, and also by one's genotype. We don't really know how. There are so many questions yet to be answered. So I think that's what makes it such an exciting field to work in.
So when we answer these questions, these many, many questions that you're saying are still there, do you think we'll stop giving teenagers such a hard time? Because it's almost as if the way people talk about teenagers, it's almost as if they were never teenagers themselves. But there are some characteristics about being a teenager that are cross-cultural, but we're so negative about those years.
When I talk to teachers and parents and even teenagers themselves, one of the things that is apparent is that this information that the teenage brain undergoes so much change, it's just not out there yet, really. People don't know this. If you go back 15 or 20 years, the explanation for sort of teenage typical behaviour like moodiness and self-consciousness and risk-taking and peer influence, that was all put down to things like hormones, changing hormones, raging hormones, and also social changes, like changes from primary to secondary schools. But we now, because of the new neuroscience evidence, we now know that behaviour has at least in part, is at least in part due to the changes going on in the teenage brain, and they are natural, inevitable changes that are driven by evolution. So the idea that, for example, risk-taking and peer influence are somehow bad behaviours, we don't really think of them like that. We think of them as necessary behaviours to become, over the teenage years, over adolescence, to become an independent adult. You need to take risks, and it's important to affiliate with your friends, and that's where peer influence comes in. So these behaviours have adaptive value.
So what are the most fun things you've kind of seen in experiments, or that you've kind of come across, as sort of the comedy side of neuroscience? Where have you got some fun experimental results?
There is, a apparently sort of comedy side of teenage behaviour. People find it really funny that, for example, if you look across species, you see examples of teenage typical behaviour that we associate with human teenagers, like risk-taking and peer influence. So, for example, a study by Larry Steinberg and his colleagues a year or so ago showed that adolescent rats, so rats go through adolescence for about 20 days, adolescent rats drink more alcohol when they're with other adolescent rats. And that's not the case for adult rats, So people find that funny because it's, mirrors what we think about human teenagers, human adolescents. But actually there's a really serious side to that finding, which is that these behaviours are universal, not just across cultures. human cultures, but also across species. And that supports the idea that there's somehow these behaviours like risk-taking and peer influence are somehow adaptive. They're in evolution. They have evolutionary value.
Who knew that rats were hanging out with their mates getting drunk for 20 days
Totally.
when they were teenagers? It's such a great fact to know. I'm really glad you've told me. So finally, my last question is this. So here we are on this beautiful campus in Edge Hill. It's graduation day. What's your advice? What's your advice in terms of moving on from this point? You leave the safety of education, now you're out there and you're kind of deciding what you want to do. What's your advice? Because whatever you've done it really well.
Well, one piece of advice I was given by my PhD supervisor, Chris Frith, who is my, number one mentor, I guess. He gives brilliant advice. He just sort of knows everything. He's totally wise. Everyone who works with him would say that, not just me. He once told me when I was doing my PhD never to worry about, and I was like panicking about what I was going to do in several years' time, and he advised me never to worry about anything beyond the next 6 months. And I think that's pretty good advice, because you just don't know what life is going to throw at you. You have no idea what's going to come up, what opportunities are going to come up, or what stumbling blocks are going to happen. And that would be my advice following Chris Frith.
So enjoy the moment. Don't panic too much about the future, and see where it takes you. Professor Sarah-Jayne Blakemore, thank you very much.
Thank you.